So let's start today. Okay, so we're going to start the second workshop on ImageJ. And again, I just want to first start again by reminding you guys about the Center for Open Bioimage Analysis, just so you know that this is now a collaboration between the ImageJ and Cell Profiler teams. So you can go to openbioimageanalysis.org and take a look at our new center, which is really focused on aiding cell biologists and their growing need for sophisticated software for light microscopy image analysis. So if you're interested in collaborating with us or getting help, please visit our website. So let's start today's workshop. We're going to start with, it's two parts really. So the first part, we're going to focus on segmentation and the classic segmentation methods. And then the second part will be on scripting in ImageJ. So this is really just an outline of a typical pipeline. It's a simple schematic of what we will cover today. So the basic steps of the majority of segmentation protocols and pipelines. So, and remember, I want you guys to remember through all of this that it is not a linear, necessarily a linear development when you're building up these workflows. As you move forward, you often have to go take a step back to the previous step and reevaluate them, like earlier steps, and see what their impact is on later ones. So you're kind of always going back and forth as you're building these pipelines. But usually the first step in the classic segmentation process is pre-processing. So actually, I think Chris also sent you guys a link to the sample images. There's a link here in the slide for you to download. There should be a zip file that contains 5 images. So if you actually click on the link in this slide or the one that Chris sent you in the email, just download those images so you can actually work along with me as we're going through this. And we also will be using those images in the next section, in the scripting section. So the one image we'll be looking at in particular in these slides and like kind of building our pipeline is the C5 image, the last image, number 5. Again, open that image in ImageJ using bioformats, ideally. But just to start off, so this image, what we're going to do is try and segment the nuclei. So this is just a DAPI staining. And it's a fairly clean image. So in theory, we could actually skip to the next step. We wouldn't really have to do much pre-processing here. And the pre-processing really is what we do to help improve image quality and improve the signal to noise ratio, removing artifacts, correcting the background levels or noise. You kind of want to do this to give better contrast so you can more easily differentiate your objects from non-objects or background. So acquisition, as you guys know, acquisition devices are not perfect and they can introduce a lot of noise and artifacts, uneven illumination and such. So typically the noise we see in images is shot noise that originates from electronics during acquisition. It results in a non-zero background. So this is something we also kind of want to correct for. So the first step, so we're going to go open Fiji and run it here. So I've got this guy. So that's my image. So I'm going to actually go ahead and open him via bioformats. So that's again, number 5 is the image you want to load. Oh, sorry, it's not this image. It's in the folder. That's the other one. This is a different example. Okay, so I'm also going to shrink this guy down a bit. And I'm going to change the let to grays. It's just easier for me to see. So usually when you're working in these pipelines as well, it's really important to duplicate your original image and then work on that duplicate. Some of the actions that we do in ImageJ aren't undoable. So you can't necessarily go undo them and go back to what your image was originally. So what I do by default is always just duplicate my image. That's like, as I'm working through and building up my pipelines, I just duplicate each one as I go until I'm happy with the process. So the first step we're going to do is apply some pre-processing filters. So there's a lot of different filters that are available through ImageJ. If you actually click on the drop-down menu at the top, process, and then filters, there's a whole list of different filters we can apply. So they're good for different things, right? So for example, the median filter is really good for smoothing out noise. The Gaussian blur, which is what we're going to use today, is really good for background subtraction, but it's not so great at preserving edges, right? Because it kind of blurs things out at the edge. So if you're interested in preserving the edges of your objects because you want to measure shape or area or something, a filter like Kurohara is actually designed to preserve edges. So yeah, so there's like a whole list of things. You can read up all on them in the ImageJ user guide. But it's important to note that these filters and these pre-processing steps aren't magical, right? So they can't perform miracles and add something that's not there in your image. All of these steps aren't replacements for good acquisition. So you want clean, nice images to start with. As we always say, junk in, junk out, as far as like analyzing your data. If you put junk images in, you're going to get junk data out. So in our case, we're going to actually just apply the Gaussian. We're using the default settings, which is a sigma of radius 2. So you can increase the sigma, decrease the sigma. We're just going to use the default because it'll just help blur out, you know, the little punctate staining and the dappy staining. And then again, we're going to duplicate now and move on to the next step. So as you can see, we're building up. So we have the original here, then we have the Gaussian blur here, and now we're going to do the next step, which is thresholding. So we talked about that last week. So basically thresholding an image is, again, picking off a cutoff value, right? Saying delineating an object from a non-object. So we want to separate the background from the objects of interest. So again, we're going to threshold this image just like we did last time. So this guy we're going to threshold. And we're just going to use the auto again. And then from there, let's say, okay, we're happy with that selection. You can see it's blurred, you know, the edges of these nuclei are a bit blurred out, but let's say we're just mainly interested in measuring the intensity within. That should be fine. Again, the default method is based on ATSU, which is really good for nuclei segmentation, like I told you last week. So we find that threshold that we're happy with, preferably and should be using automatic methods. And then right straight from here, we're going to create a mask. So we just type in create mask. So now we have a mask of our objects. So otherwise known as a binary mask or a binary image. So all those terms are kind of, you can use them all. So you can, it's a mask is a binary image, binary mask. So what we have now is an image that is only made up of, the pixel values are only made up of numbers 0, and in the case of ImageJ, 255. So binary images are just like literally just ones and zeros, but in ImageJ, our default is 255 for a pixel value. But it doesn't really matter because either you're 255 or 1 or you're 0 in this case. So the only thing we know now about our objects, we have no intensity values. We don't know any of that. The only thing we know is about the shape and, you know, size of these objects. So the morphological operations. So those are the type of operations we can carry out now on these masks to help clean up our objects. So there's a whole host of those operations. If you go into process binary, because now we're working on this binary image, this mask, there's a whole host of different algorithms we can carry out. For example, erode and dilate. Erode and dilate are to either reduce or grow, respectively, objects by a single pixel. So that helps you kind of smooth out edges or destroy very small structures when you use them sequentially. And it doesn't mean you have to use like just erode or just dilate. You can use multiple erodes, multiple dilates. You can use them sequentially in any order you want. Open and close are also, I don't remember which one's which, but one is an erode followed by a dilate and the other one is dilate followed by an erode. So those actually really help the very quickly smoothing out sharp edges and small kind of structures on your objects. There's also fill holes. It does just that. So if you have like a donut structure, it'll fill in the area in the center with, you know, value of 255. So you, for example, you can use this, you have a membrane staining and you want to use that to calculate the whole area of the cell. So you can fill in the cell using the fill holes. And sometimes though, just so you know, the membranes don't really, the membrane staining or ring staining, any kind of ring staining you're doing that you want to fill holes, if it doesn't completely connect, it won't fill in the hole. So then you can use a rodent dilate to try and close the ring and then successfully fill in the hole. And then the final one I want to highlight today is what we'll use today is watershed. So as you can see, we actually have two nuclei in our image right here that are touching. So right now they're actually would be counted as a single object, but we want to make sure that those are actually cut into two because we know that those are two nuclei based on the original image. So we're going to use watershed to actually like segment the two objects that are almost touching. So it's a way of separating or cutting apart particles that touch. Technically, what it does is it finds the Euclidean distance map and then finds the ultimate eroded points. It then dilates those ultimate eroded points, which are basically the peaks of local maxima of the Euclidean distance map. And it dilates them as far as possible until either you hit the edge of the particle, so the edge of the object, or the edge touches another region, growing region, adjacent region. So then it basically creates a single pixel cut. It works best for smooth convex objects that don't overlap too much. So more circular kind of objects. To better illustrate this, we can actually show you how it works. If we go to edit options and then miscellaneous, we can click debug mode and then run the watershed algorithm. And this is going to show us exactly how it's working. So it's going to generate, it's going to generate this extra movie. So you should see that, yeah, if you zoom in here, you'll see that those two objects now, since we ran that watershed algorithm, are now separated by a single pixel line. And then since we ran it in debug mode, this little video popped up. And this is actually showing us how the regions grow and how it's selecting the cutoff region in those two blobs. So just kind of a fun thing. So you can actually visually see how is watershed working. You don't have to run that when you're actually just doing watershed. It's just for us to see. So now let's say we're happy with the objects that we've separated them, we've smoothed them out, we've done all these morphological operations and we're happy with our objects, and now we actually want to measure them. So we want to split them, we want to identify our objects and split them into individual objects, because right now as a mass, it's an entire region that's shared, but we want to say count our individual cells. So we're going to use the tool called Analyze Particle Analyzer. So it will help us split up our mass again into individual objects and then save those objects in the Roy Manager, which we talked about last week, and then we can do the measurements. So we will run Analyze Particles. So you're going to see it's a pretty simple tool. You can filter out objects, the selection of objects based on different features, such as size. So we can set, like if you just have like small punctate staining that you want to ignore, all the way up to very large objects you can ignore. But it's important to note that if you are actually wanting to measure the size of objects, that you don't want to introduce bias by pre-filtering them things out, right? So it's important to kind of leave that alone if shape and size, or size is something that is important in your measurements. Then you can also filter on circularity. So from 0 to 1, 1 being more circular objects. And then I also wanted to note, remember how we talked about last week update sites, and there was one update site I think I mentioned called BioVoxel. So BioVoxel has what's called an extended particle analyzer. So I linked that in the slides. Here, I'll just click the link for you to see. It actually has a particle analyzer. So Jan built this extended particle analyzer, which lets you filter on many even more criteria. So if that's something that interests you, you should enable that update site, the BioVoxel update site, and then you can get access to this extended particle analyzer, which is a great tool. me just whoop, get the slides back. Okay. Okay, so particle analyzer. So what we're going to do is set actually a low cutoff value to 200. And we are going to add our objects to the manager. So this is adding them automatically to the Roy manager. We're going to exclude objects that are on the edges. So for example, this nuclei, we don't want to measure, right? Because we don't know what's going on outside of the image. So we want to ignore any of the objects that are potentially touching the edge and show nothing. And we'll just leave those settings just like that. And now you'll see we have highlighted objects here in yellow, and they're all listed here there. Well, they're not saved there until you save them, but you can save them going to more and save, and then reopen them later on. But let's say we want to measure the intensity, right, of these objects. So if we go ahead and we deselect, usually you always click deselect first, because if you accidentally highlight an individual or a few objects by highlighting them like this, it'll only measure, if you click measure, it'll only measure those objects. So just to make sure that you're not picking a singular object to measure, you just have to hit deselect. So no one selected, that means you're going to measure everybody. So deselect and then measure. Okay, and again, you guys can change the measurements that are calculated with set measurements. So as you'll see, like this is weird. Like I wanted to measure the mean intensity of my nuclei, but when I went to measure, it's logging them all as 255. Well, the problem is that I'm measuring the binary mask, right? We need to overlay. That's why this Roy manager is great. We want to save those objects because we want to overlay them and actually measure on the original data set, right? So let's just close these measurements. And that's also why the duplicate is nice in the beginning when you're building these pipelines. Go back and select that original image. Open your Roy manager and just toggle the show all, and you'll see the objects get overlaid, right? Our Roys are now overlaid onto our original image. So if we deselect and measure, now we have the mean intensities, the correct mean intensities of our nuclei, and a count, obviously, of the nuclei as well. So yes, so that's pretty much like a classic segmentation protocol. Now in all of those slides, I have links at the bottom as examples of different different tools you can use and things. So I hope you can just use these slides as a resource when you're building these types of tools. But at this moment, I'm just going to take a quick pause because we're going to then move into scripting with ImageJ. But I just want to take a quick pause and see if anyone has any questions at this point about any of the segmentation stuff, because now what we just did, we just built this quick segmentation protocol of those nuclei. So now what we're going to do is learn how to script and batch process that. So we're going to process those 5 folders automatically, doing all those measurements with a click of a button, as opposed to having to go through and click each step for each image.
Nothing in the chat. Does anyone have any questions that they would like to unmute and ask? Okay, we have one in the chat. How would you apply this segmentation to a stack? Oh,
that's a good question. So yeah, you can do it per slice. So, but are you when you say to a stack, do you mean like you want 3D volumes, or you want to process
yes.
each slice of an individual? Yeah.
So what I was asking about was, so for instance, you have all of those nuclei in a single slice in there, right? So if you had that image taken over a Z stack, rather than putting all of them into one plane, could you, I guess, measure the intensities of DAPI and those nuclei over the stack? Or do you have to compress everything into one plane and then measure the intensity?
Yeah, so I guess it depends on the biological question that you have, whether or not you could actually just do like a Z-plane projection, right? Mm-hmm. And then do the measurements, or if biologically speaking, you need per slice information, but you can apply exactly what we just did to a Z slice and save the Roys from each slice, yes.
Okay, and then you just add them all up. Is that the way you would go about it?
Again, it depends. It depends on what your question is, biologically speaking. So
Well, so the reason I was asking is because, okay, so I was looking at like a field of nuclei like that. I was looking at a signal that was within those nuclei. And usually if you have a Z stack and then you kind of compress all of them into one plane, it asks you whether you want average intensity or maximum intensity or, whichever one, right? And so I was wondering if, like, based on how you choose those things, let's say if I chose maximum intensity, is it changing the data, I guess? Because then if you put them on and you do maximum intensity and then you measure it's not going to be the same as if you measured each individual plane, is what I was thinking.
Correct.
Right.
Yes.
So how would I deal with that data is what I was trying to figure out.
Yeah, so I think that, for example, is an excellent question to pose on the forum and like gauge the community and what they think is the best answer for that. Personally, if you're looking at, I think I remember reading something like this on the forum, and I believe people used average, like an average projection to do those types of measurements. But that's something that, it would be good to ask the general community to see, like, what is the accepted, based on the biology and what I'm trying to measure in my images, what would be an accepted method to use. But I'm pretty sure it's the average projection.
Oh, okay, excellent. Thank you.
But don't quote me on it, just double check, but I'm pretty sure,
Okay, thanks.
Yeah. But again, it all depends, all these things, that's why each protocol it's different based on any single, it depends on your data, right? And what you're trying to measure. All these protocols, these pipelines that you build are very specific, right, for what you're doing. But overall, these are the general tools that are applied.
Okay, thank you.
Yeah. Anybody else?
We have another question. It says, can applying filters change original information? For example, if we quantify intensities?
Yes. Yes, they can. So it is, because you are changing the pixels, right? You're applying, you're basically doing maths to the pixels in your image. So it will affect it for sure, which is why it won't affect how you build your mask. Do you know what I mean? So it'll affect how you build your mask, but it won't affect how you measure your final intensities. Because remember, when we blurred our image, right, and tried to improve our signal to noise ratio in order to segment our objects. And once we had that segmentation, we had those ROIs, we applied the ROIs to the original image, which we did not touch the pixel values to, which is why you want to actually do your measurements on the original image that you did not apply any of those pre-processing filters to. Does that make sense?
Yeah, thank you so much.
Okay, yeah. So that's why I always personally duplicate my images as I go when I'm building pipelines, because then again, not only is it that some functions commands can't be undone, but then you can always get back to that original data that is completely untouched. You don't want to mess with that data at all on that original image, but you can save everything subsequently. Can you measure the volume of an object from a stack? Yes. I mean, presumably if you have a calibrated image, you should be able to quantify the volume based on like the number of slices and the areas. Is it possible to identify area of interest in an image? For example, when you're looking at tissue, you may only want to evaluate a portion of it. Again, that depends on how well you can delineate that portion. If you're looking at, it depends on your image, like how good is the signal to noise of the region that you want, or are you better off using the tool we talked about last week, like a machine learning tool to actually draw on that region and say, no, train the computer to select that region. So that's really data dependent. Okay. Are there any other questions?
There's one more that I think we might have missed. It says in most cases the nucleus, so DAPI. Are you?
Yeah, the nucleus DAPI is co-incubate with many antibodies. Does the area of the antibody need to be removed first when only the antibody's intensity is measured?
Sorry, I think I have read it wrong. The question is, does the DAPI nuclear intent or area of the nucleus should be removed first but only the antibody intensity is measured. Yeah.
Yeah, so
So-
all you'd have to do, so if you want to use the nuclei to, obviously you want to use the nuclei and then segment the nuclei, but then overlay that on a second channel and measure the signal of this other channel within.
Yeah.
Yes, you can do that. And if you in that case, you'd only be measuring, I mean, you can measure as many channels as you want, but as long as you don't have overlap in your antibody signal, you know, with DAPI is a pretty broad, has a pretty broad readout. So it's possible. So you just have to check your antibody, you know, like the, I don't know what the words are. It's escaping my brain, but to the signal from DAPI and your particular antibody, whichever fluorophore you're using. So you can easily distinguish what is signal coming from DAPI and signal coming from your specific antibody.
Yes, thank you.
Okay. I think there's tools out there from some of the, from some distributors that allow you to check the overlap. Okay, in an image with a crowded set of cells, is there a method of watershed that provides more fine control? Yeah, there's different, yeah, the method I showed you is the built-in, that's how the built-in watershed ImageJ works, but there's tons of different watershed algorithms. Like there's different ways watershed can be applied. So there's one tool, I think I linked it somewhere in the slides. Let me go back. I think it's morphological segmentation, Morpholib. So Morpholib is a plugin. I think it comes directly with Fiji that has many different watershed algorithms, like different options of doing watershed. So that would be something to look into. It's also a really well-documented plugin. It's actually created by the same developer who built the trainable Weka, the machine learning plugin that we used last week. He's amazing. So there's a bunch of, yeah, there's different methods that'll allow you to have a better control, yeah, in that case. So Morpholib is a great tool to check out. I'm sorry, I didn't mention it before. It's good you asked that. Okay. We good? Okay. Let's go ahead with scripting then. So actually we just want a quick gauge you guys to see how many of you have scripted before. If you can just like do the little like hand raise thing in Zoom. You've scripted before, okay. Okay, and then just lower your hands. And then those of you who have never scripted before, this is like something that's new, or you've had minimal exposure to coding. So, okay, there's a few of you. Okay, that's good. So hopefully this won't, I'm gonna go over some of the basics just because if there are a few of you who've never coded before, this is new, it's important to go over. For those who are more advanced, you guys can just kind of play around with the code a little bit on your own. If it gets a little boring, I'm sorry, but there's links and stuff in the slides too for you guys to check things out. But I just want to make sure that we're covering definitely the people who have never scripted before. So this is actually how I started scripting. So now I code in Java and in Groovy and Python, but I got started scripting just in ImageJ. So the stuff that we're going over today. Okay, so why are scripts useful? So again, just make sure you guys have those data sets saved if you want to run these scripts for those nuclei images. So just work on downloading those and unzipping that file. But okay, let's start. So why are scripts useful? So basically they help facilitate reproducible science. So the three main things in my mind that scripting is great for is one, it helps you document your work. It helps you remember what you're doing and why, right? So they're kind of like your lab book for computation. You'll see that we can add comments that are written in like our normal language, reading language. So you can write down in scripts, you can write down exactly what you're doing, which is the code. And then you can remind yourself and others why you're doing it that particular way using comments. So always thinking down the road. You don't want to just write scripts. It's like a lab notebook, right? You're not going to remember why you change the protocol volume from 15 ml to 20, maybe 3 or 4 months down the road, which is why we write it right in our lab notebook. This is the reasoning behind that, right? It's the same for your scripts. Always think ahead. Think about yourself in a few months, reading the script again and kind of seeing quickly how it works and why. Number 2, scripts help, most importantly, I think, automate your analysis, right? This is why we all get into this stuff, is because you can run this code on multiple data sets with just a single click of a button. So yes, you have to spend a little time writing the code, but once you get over that hurdle, it saves you a lot of time. Then you don't have to do each step manually, right? And you could batch process folders of images. And another great thing about scripts is that they can be shared, not only within your lab or with collaborators, but actually into the world through your publications and just openly available online. So to actually script in ImageJ, we use a tool called the script editor. So we can actually go ahead and open him in ImageJ. So we're going to close this, just close all. We're not going to save the ROIs or the measurements or any of that stuff. So the shortcut for opening the script editor is just the left bracket key. Oh, well, or you can write new script or just script ... So if you can also hit just the left bracket key. So that'll open the script editor. It just went into the search bar for me, and which was not very helpful. So this is the script editor. So essentially, it's like a glorified text editor. So what it does is help you write code. Everything is syntax highlighted and colorized, so then you know what the different pieces of code are. It gives you hints. The colors indicate, what the different pieces are. It's more than just a simple text editor. It's really going to help you build your code. And like we have code completion now, which is huge. Sorry. And we have all the different languages that you can script in ImageJ. Today, we're going to be doing the ImageJ1 macro language, which is a limited language. We can only really use it in the context of ImageJ, but it's a really great language for using ImageJ and if you're new to scripting. But if you're good at scripting in Groovy or Python, you feel free. And there's tons of templates and the different languages that are built in, and we're actually going to take advantage of one of them or a couple of them today. So you don't have to start from scratch, from zero. So yeah, we'll be using the ImageJ1 language. So to start though, we're gonna go over some of the very basics in scripting and coding, comments, variables, functions, string manipulation, conditionals, and loops. So maybe some of this stuff will be good for those of you who are already adept at coding. Maybe there'll be some nice reminders and things, helpful things. So just bear with me. So we'll start with comments. So we can highlight this code. Oops. I'm gonna just escape here. You can actually highlight the code and we're just copy and paste it and put it into the editor. So can you guys read my editor? Is it too small?
Yes.
You can read it? I'll just increase the font size just a little bit.
Yeah, that's good.
That's better. Is that, maybe that's excessive. But we'll just start with here. Okay, so comments basically allow you to put human readable thoughts into code, right? Code is just that, it's code. It's meant to be harder to read. So comments are just like 2 backslashes, at least in the ImageJ1 language. Again, make sure you have that same, that ImageJ1 macros language selected under the language drop-down menu. And then you'll see that it is colorized, the text, so comments are in green. So what's great is that comments can be added before lines, but they can also be added in line. So after your actual code call, you can say, okay, I'm assigning this value to because of this, And I use comments a lot for is when I'm actually writing my code and editing things, you can edit out code calls. So let's say, okay, I don't want to use this code. I'm in the middle of writing like a big script and pieces of my code aren't working. You can just comment them out as opposed to deleting the line, because you never know if you have to go back to it again and like, oh no, I do need that little piece of code, but I can't remember what it was, you know. So it's easier just to just comment it out. Okay, so when you're editing, this is really like a really helpful thing. So yeah, use comments to help you remember like why you're doing what you're doing. Okay, variables. So what is a variable? Well, if you look at this piece of code, so this is if you're changing the LUT. So this is the code that gets actually printed off. So it's a run function, and the things that change if you switch the LUT from blue to fire, the piece of the code, right, that's changing here is within these parentheses. So that kind of hints that you're using the same command and function, but you have one little piece that's varying. And so therefore you can use a variable to replace that changing piece, okay? So basically a variable is a container. It's a small box defined by a name that can contain information. So it's a piece of code that can vary, essentially. So in code, for example, like this, in this example, this code example, we have the variable called color, and we're assigning, which is the equal sign. So it's not like in math. In this case, it's like assigning the value blue to this variable color. So if we do that run color call again, now it'll change the LUT to blue, right? Because this little variable is holding this information that we're passing to this function. And there's two main types of variables, numbers and strings, at least in the macro language. Again, this is all in the context of IJ1 macro language. And strings are typically surrounded by quotation marks, like blue is the string in this example. Okay, so now let's play with the code a little bit. So you can actually go ahead and copy and paste that next slide's code into the script editor. And we're just gonna go top down and read through here. So there's different values, like I said, there's two types. There's strings, which are surrounded by quotes. And in the colorized text, they're pink, and then numbers are purple. And then we also have expressions. So you can actually use variables within expressions and then assign them to another variable. So if we're actually going to run this, we're going to actually get a little error. So this is something the script editor helps with too, is giving us hints if something in the code doesn't look right. So they're saying there's an undefined variable in line 4. Well, yeah, because we read code from the top down, right? And we never told the computer what value X and Y hold. So the first expression, the first variable it hit was X, which is why it's highlighted here. So it doesn't know what value. So if we assigned a value to X, Y, and A originally in this case, it could actually do the expression, but it can't now because we don't know. Okay, so we're just gonna comment that one out. And then, yeah, there's difference between string constant versus the variable name. So if we just add some print lines, so if we add print, so it'll print out what the variable text is held. What will be printed if I go ahead and print this. So we're saying the string title, we're going to assign it to this variable text. And if we print text, it should print out the word title. Exactly. And if we go ahead and print, or actually we're going to move the print statement down here. So now we're saying we had text assigned with this string title, but now we're going to actually reassign this variable text to whatever value was held within the variable title, which is up here. We declared it up here, right? Hello world is title. So what should get printed now if we print text should be hello world, right? Because we're reassigning it with that second, with line 8. Okay, so we're using another variable to reassign a value of that variable. Okay, and this is kind of the same idea. So we've got, we're assigning the number 3 to X. We're saying whatever value is held within X variable, we're going to assign it to Y, right? So if we print X and print Y right here, They should be the same, right? Exactly, 3 and 3. So they should be identical. But it's important to know too that they aren't variable values and things aren't linked. So they kind of run independently. So if we assign now X to have a new value, 5, what should Y, the value of Y be after this? Well, it should stay the same as it was before because we didn't reassign it again. So yes, so it's going to be value of X has changed, correct. But the value of Y has not. It is not linked in any way to the X variable, if that makes sense. So it's independent unless we reassign it once again. And then at the end, of course, you can actually use, like we did above, like you can use a variable. The variable is assigned after the expression is evaluated. So first, you always evaluate the expression, and then you assign whatever the value is from that expression to the variable with this equal sign. So if the intensity is 255, what we'll do is 255 times 2 equals, and then we can print it. So after that expression, the value should be 510. Right, so we can use a variable itself in the expression as long as it's been assigned a value before. Okay, so those are variables. Yes. Got a little lost here. Okay, now we're on to strings. So we're just going to play around with strings for a little bit, copy and paste this code. Okay, so the thing about strings is that you can actually link them together. And that's called concatenation. So you can basically take two strings and link them together into a single string. So if we go ahead and print, actually, the first thing I'm going to do is comment out these 2 bottom run calls. Okay, so they end the print calls, just so these functions don't keep popping up each time we run it. We're just going to do piecewise. Okay, so we're going to focus up here on the top. So if we print out text, right? So at the very first line, we assign the string variable, the string copy to the variable name. And then we're going to concatenate it to this string. So again, this is an expression here on the side that we're going to evaluate first and then assign it to the variable. So we have a string called the name is, and we're going to concatenate using the plus sign to whatever string is held within this variable name, and then assign that whole string to the variable text. So if we print out text, it should print out the name is copy, right? Because we're actually linking it there. Okay. Okay, and numbers versus strings. So this is kind of like dealing with math versus dealing with strings, right? If you do the first print statement, what should you expect this expression to be? The answer will be printed off. 5, right? Because it's going to do the math. In this case, it's A and B are both holding values that are numbers. So it's actually going to go ahead and do the math. Well, if you say those 2 values, I want to go ahead and comment this out. These 2 values are actually strings. So this is different. Then the plus sign is you're no longer doing math, right? You're doing concatenation. So you're merging these 2 strings, whether they're numbers or not doesn't matter because they're held within quotes. So the computer sees them as strings. So then when you print this, it should be 23, right? Okay. And then finally, so we're going to run the duplicate on our, we'll just run the first duplicate first. So we're actually going to open the example image blobs. And then when we do this duplication, so this is what the actual duplication call looks like, the code call. So it's duplicate ... and then title equals name. So right now the title of our image is blobs.gif. So if we run the duplication, it should then print out, or it should then create another image with the title called name. Okay, but then knowing what we know about concatenation and what happened before, what's going to be different here? So we're not, this is an actual, so the previous one was actually saying use the string called name, right? I could change this to big blobs, right? And then it'll print out big blobs, right? For example, big blobs, right? So that's actually just reading it directly as a string. But what the second run call does is do the concatenation. So we had declared already this variable to contain the value copy. So if we run this one, the new image should be called copy, right? Because we're concatenating whatever variable, whatever value is in that variable to be the title of that new image. Okay. Okay. Okay, functions. So functions, we've actually talked and used a bunch of functions already. So a function basically takes some inputs, performs an action on them, and results in an output. So what's cool in ImageJ is that you can write your own macros or your own functions, sorry. And this is kind of the verbiage that we use. So you start with the word function and then the name you want to call the function. So you have to say function to declare that this is a function. You can name it. So in this case, we just say my function. And the convention is that you start with a lowercase, and then for each word thereafter, the first letter of each word is capitalized without any spaces or dashes or anything. Obviously no spaces, but no dashes or anything. And then you provide the arguments, which is the input for your function. And then the actions, the things that you want to carry out, go within the curly braces. So this is just a really silly little function I made up. It's a short example, right? So we have, we're going to call our new function setLut, which we could just run the run one, but let's say there's lots of different run calls in ImageJ. So let's say we want one specifically to setLut. That's all it will do. We're going to give it an input LUT name. So that is blue, gray, whatever we decide to this variable. And then we're going to go ahead and run the function to reset the LUT. Okay, so that's just like a silly little example. But we can actually go ahead and copy and paste the code in that slide. So what we were doing, so again, I'm going to just comment out the last two calls. So all those print statements we were writing out, that's a function. Print is a function. So if you run that one, I'm going to just comment out it's going to print out hello world. That's a function we're calling. So I'll comment that one out. We'll uncomment the number one. So functions can also return values. So you can save the value that's called from a function. So if it returns a number or something, you can save it in a new variable. So if you actually run this function, get number. So if the user types in, 210, that's going to be saved in that number variable, sorry. So we should actually print it out so we can see that changes based on what the user inputs. So the default, the convention here is default 5. So let's say we change it to 210. It should print out 210, right? Because that's what actually is getting saved into this new variable number. So saying that, I actually forgot one little piece. There's a link here at the bottom of the slide, the function slide, a built-in macro functions. So this thing is like, if you're writing a script, you have this page open because this is basically the ImageJ1 macro language, right? Every single function call that we do manually, all the code calls are here in this page. So what's cool about this is that you can just search for a function. For example, let's say, we just call get number, right? So let's look for that function call, get number. So this actually tells us what's the convention. How do you use this function? Displays a dialog box and returns the number entered by the user. We just saw it happen, right? So the first argument is the prompt message, which is what we saw. And the second is the value initially displayed in the dialog, so the default one. So in our code example, it was 5. So this is really a handy thing if you're like, I know I want to do draw a line and remember how to draw a line. So then you can just search in here for line and find the code call for drawing a line and get that, the 2 different X and Y coordinates, and then you know exactly how to do it. So you don't have to remember exactly how to call the code. You just have to kind of generally remember what you want and then search for it in here, and then it'll help you. It'll just ease your scripting. Okay. So yeah, so here was that get number call. So I'm going to just comment this guy out again, and we're going to run these duplicates at once more. So this also, again, is a function call, these run duplicate. We're going to open that example blobs to run it on. And so if we run this one, now we're going to open a new image, and it's going to be called new, right? That should be the title, right? And so there's also a way to to run this code call and actually include spaces in your script or in your title of your image. So if you actually if you use these brackets, you can actually include a title with spaces, if that's important, right? So that stuff's it's all described in that built-in macro functions page. So you don't have to remember all these little things. There is a resource out there for you to help you remember. Okay. Whoop. Sorry, I just got to get the slides back. Okay, conditionals. We're almost through this basic stuff. So conditionals. So basically, these are those types of statements like if the value equals this, then I'll do that. But if it doesn't equal that, if it doesn't equal it, do some other thing, right? So that's essentially what a conditional is doing. If this, do that. If not, do something else. Okay. So they're if else, they're written as if else code blocks. So in this case, we have what it's asking is if, so we're getting a Boolean, so you can search for that also in the built-in macro functions to see what it does, but it's asking a yes or no question, basically. Is the instructor going too fast? So if the answer is yes, if the person answers yes, then you need to tell that instructor to slow down. If the answer is no, well, then you can then the hint will be try to modify the code and play with it. So we can run this. So instructor names Todd. Okay, great. So is Todd going too fast? Say yes. Well, I'll tell them to slow down. So that's the advice that's printed off because of what's saved in this hint variable. Okay. You can also add if statements. So if you want to even get more specific, you can say else if instructor equals, for example, me, Ellen. Well, then let's make the hint really nice. So let's say give Ellen a high five. Let's be nice, Ellen. So if we run this, so Todd, of course, that won't call. So let's say it won't get called, right? If it's Todd. So if it's Ellen, we say, is Ellen going too fast? No, give Ellen a high five, right? Because if it's Ellen, we give her a high five no matter what. Okay. So those are conditionals. And finally, we are doing loops. So there's two different kinds of loops. There are for loops and while loops. But really, they kind of do the same thing, just in two different ways. For loops, which we'll start with first. So I'm actually going to highlight all of these lines here. And if you hit, I think it's shift. Nope, undo. Okay, never mind. It's command backslash. Then you can actually comment out multiple lines. At least on a Mac, it's command backslash, as opposed to having to comment out multiple lines. So you can comment them back in and out by just holding shift and then hitting the backslash key. So we're going to focus on the for loops first. So for loops are good when you know the number of times you want to loop. So what they use is they're structured as they use an assignment, which is right here, this I equals 1. Then they test, so is something true or false, right? Is I less than or equal to 10, true or false? And then they increment, so then we add 1. So plus plus is what adds a single element, so 1 to I. And then for each line, we're going to print what I is. Okay, so if you run this, it should print all the way out to 10 and stop at 10, yeah. But if we were to say outside of the loop, print I, what should the final I value be? Now remember, every single time we do a for loop, we have this assignment, test, and then an increment. So for the final for loop, even though it only prints out, you know, counter equals 10, the final for loop, I will actually equal 11, right? Because we're going to increment that final time that for that final test, I plus 1. So the last one is 10, 10 plus 1 is 11. And then in that case, is I less than or equal to 10? No, right? 11 is not. So then we don't do what's inside the brackets. We stop the for loop. So if you run this again, you'll see the last value of I equals 11. Okay, so I'm just going to comment out this code and we're going to work on the while loop. So while loops, don't comment this back out. While loops are really good if you don't necessarily know how many times the loop will go. So you're not quite sure when you're going to hit right, or true or whatever. So or false or whatever, however you want us to structure it. So in this case, we're going to ask the Boolean is going to be, do you want to keep going? And as long as we say yes, it's going to do what's inside the bracket. And as soon as we say no, it's going to dump out of the while loop and go on to the next code. So it'll say, I'm done. So if we run this, do you want me to keep going? Yes. Do you want me to keep going? Yes. Okay, I'm still going. Okay, I'm still going. Okay, I'm still going. And then I say no. Okay, I'm done. Then just the message is printed. Okay, so that's a while loop. So you use them differently depending on what you need, you know, if you know for sure how many times you want to increment, or if you're not quite sure, and such. Okay, and then we have one final little quick example of tying it all together. If we run this code on blobs, so again, we'll open blobs. So this example basically, it says but there's an error in here. There's a mistake inside this code. So we're going to try and figure out what it is. So this example makes a stack of blurred versions of the current slice with a range of radii. So it's applying a Gaussian blur in increasing radii because we're using the for loop to increase the radii as we go. And then it's going to make a stack of images and we should see them get blurrier and blurrier. So if we run this code, so in this case, the maximum radii, we're only going to have 5 slices. So we're only going to go up to 5. So they'll just increase incrementally up to 5. So then what we have is this blurred stack of images, but there's something wrong here, if you notice. Yeah, so it jumps to a blurry image, but then they all stay blurred. Right, can anybody see like the potentially, you can raise your hand if you see where there's an error in this code. Okay, I'll just tell you. Or maybe I'm losing people, but it's right here. So a lot of the things with variables is that you want to make sure they're named. That makes the name of the variable make sense. So in this case, right, we say this radius should actually be the maximum radius, right, that we're getting back from the user. And I is what's incrementing. So that's what should actually be here when we're increasing the Gaussian, right? So each time we go through, this radius actually should be I. But what makes even more sense is to actually call this first number max radius, right? So we know just reading the code that that's our max radius, and we should actually change I to radius, right? Because each time we're changing the radius, instead of like I, which doesn't really, it's not as readable, you know what I mean? Radius and max radius, so we can kind of distinguish it more clearly. So if we actually run this again on blobs, right, instead of just increasing each of one of those slices by the max radius, which is always going to be 5 in this case, it's going to be 1, 2, 3, 4, 5, and you'll see it gets progressively more blurry as we move through. Okay, now we're getting to the good stuff. Hopefully we have enough time to get through it all. Okay, so writing scripts in ImageJ. The first thing you want to do is launch the recorder. The macro recorder basically saves all of the commands that we manually, I'm just going to go back in the presenter mode. The thing that we actually click on in Fiji, it'll save it into code. So let's go back and let's just close everything. We're not saving the changes for now. We're just going to close all. I don't know why that. Let's open something else. I'm just going to close all the images. Don't save, don't save. Don't save. Okay, so we want to open the recorder. So which is just record ... So this is the macro recorder. So there's different languages you can actually record in besides the macro language. You can also record, for now, it's only a few: JavaScript, Bean Shell, Java. But in our case today, we're going to use the macro language. So for example, let's open that image blobs. This is an example image. So we open that image. Here's the code call. It's saved. Let's apply the Gaussian, which we did before with a radii of 2, sigma 2. It's saved, right? So this is this is how you start scripting. You don't have to remember, oh, how do I write that code? Like how that code, what is that code call? I don't remember. I can't find it in the built-in functions list. Just go ahead and run it in the recorder and copy, like you can copy and paste it. We can set a threshold. Right? And create a mask. You can do all that. And all that code is going to get saved. And then what you can do is hit the create button and you have the makings of your script. It'll get opened automatically in the script editor in the language that you were recording it in. And you have like the beginnings of your code, right? So now we're going to actually execute. If you go ahead and execute all those same code calls that we did on the segmentation pipeline with that sample image, let's go ahead and do that. So let's close everybody. Oh, sorry, I canceled that. Let's just close everybody. Even the recorder for now. Because we want to make this as applicable to other images as possible. We don't want to hard code in opening one specific image. So I'm also going to just quick change the LUT to grays. Okay, now once I have my image open, I'm going to go ahead and open the recorder. And then I'm going to do those same exact steps that we did before. Okay, so I'm going to apply the Gaussian blur. You guys can go ahead and do this with me if you want. Then we're going to threshold using, we're going to run our thresholder. And we're going to create a mask. We're going to watershed. And analyze particles. With the same settings that we did before. Okay, now all those code calls are saved. So if we create, we have the beginnings of our little script that we're going to actually extend to multiple images and use for batch processing. So your script should look like that. If it doesn't, you can actually just, I have an example here where you can just copy and paste the code to make sure that it's exactly the way you see here. Okay, so this is just a quick code check, make sure everything looks the right way. Okay. And the next thing we're going to do is spruce it up. So I'm actually just going to, we're going to go through and talk about what all these different things are. Again, this sprucing up is what we're doing to kind of make it more universal. So it could be applied to multiple images and have a couple options in our code. So again, when you click the create button, then it opens the script editor. And we're going to add these things called script parameters to the top of our code call. Right at the top. So we're going to talk about a little bit more about script parameters. But all you need to know for now, it's a universal notation that declares inputs and outputs. So for example, we're going to do, we're going to use one of these script parameters to figure out, to ask the user for a minimum size of object, like minimum size nuclei, right? Or nucleus. What would they choose as a min size? Excuse me. Did I do that right? No. Let me just double check. I need to double check that I did that correctly. Yes, okay. So basically, instead of saying 200, like having it explicitly coded in, right, in your script as 200, you can ask the user now for what would they say is their minimum size, and then concatenate that variable into there. Sorry, I just did that totally wrong. So we're going to add it. And again, I should probably increase my font size so you guys can actually see what I'm writing. Right, so if we were to run this, then we'll get a prompt that says, is asking the user for min size, and we're not exclusively saying 200. We're going to use whatever input is from the user. We can also use this thing called set batch mode. So, you know, when we go ahead and run, so you'll see this is the code, the code completion. It's now based on what I'm typing, what function I want to call. So actually what we want is, well, a set batch mode, but we actually want this to say true. So set batch mode is basically stops windows from getting popped up all the time. So if you're doing something that's very processing heavy, it actually helps speed things up because it doesn't need to generate all these windows to pop up and blah, blah, blah. It'll just do the processes without popping up each individual window. But for now, we're going to just comment that out because when you're building your pipeline, you actually want to see like each step. So I'm actually going to speed up a little because of time. And just quickly go through this because the code is here on the next page. So you can copy and paste this code, which I'm going to quickly do. And we're just going to talk about the different pieces that I'm adding into the code. So I want to make sure we get through this and you guys have a workable piece of code. So we added the script parameter, right? Min size. We added the set batch mode to true. Now to generalize the script even more, we're going to use this thing called a get image ID. So we're going to get the original images ID. I'm just closing all the other stuff for now. We're going to get the original images ID, and then we're going to duplicate that image so that our original image is set to the side and we work on the duplicate for all of the rest of the script, right? So on the duplicate, once we have that image, we'll apply the Gaussian blur, do the thresholding like we did before, create the mask, watershed, analyze particles. And then this is the new code from lines 12 to 16. So from here, we're clearing the results in case for whatever reason you were doing measurements before and there was results were printed in the results table. We just want to make sure anything gets wiped out, it's erased, so we can print our new stuff. And then we're going to select the image, basically by selecting this image using the ID, we're activating the original image that was untouched, right? Not the duplicate we were working on, but the original image that was untouched. And we go into the ROI manager. So we saved all our ROIs in the, via analyze particles. We're going to show all those and overlay them onto the original image. Deselect again to make sure none were accidentally selected so that we can measure them all. So if you actually run this code, I'm going to open up that original image once again. Okay, and if we actually run this code, you'll see the minimum size default will be, in this case, 200. So I'm just going to leave it at 200. Done. Voila. So it automatically did all of those steps without popping up the windows because we use set batch mode to true. And here we have our results saved, done. And all of our ROIs saved in the manager with one click of a button. And the cool thing is this is generalized. We can apply it to any image, right? And we can actually batch mode process that script. So we're going to do that in a minute. But first, we're going to take a quick step back and talk about script parameters because these things are super helpful. So this is what we use to ask the user for an integer input, right? But there's a whole host of things you can ask users for, and they're generalizable to any script, any language. So we're going to actually open the template that's available via the script editor. It's in templates, intro, and widgets. So if you go to the script editor, drop down menu, template. What did I say? Where is it? Sorry, templates, intro, and widgets. So either one, Bean Shell or JavaScript, will just open the Bean Shell one. Because it doesn't matter the language. This is read by any language, whether you script in Bean Shell, Java, Python, ImageJ 1. It's these top 24 lines that you care about. These are all the different types of script parameters that you can call to interact with your user. In fact, there's another one. There's even another one, I think, date, that's not listed on here. I think it's date and then date. So this will actually give you like a calendar. So if you just run this, it shows you what's generated through the GUI, right? By looking at these. So here's the date. So then you can pop up a calendar and pick a date. You can select a file, browse for a file, you can ask the user for a file, different colors, different integers. You can ask them for strings. And what's cool here is that you can also have like slider values, for example, for this integer one that's labeled int. You can actually add, oh no, sorry, it's a bounded integer right here. This guy, this int is a bounded integer. So basically you say you have cutoff values, right, between 0 and 1000. And in this one, you can actually add a style to it as a scroll bar. So if you run this again, you'll see now this bounded integer, you have the user just use a scroll bar instead of just typing in the number. So there's all sorts of different cool things you guys can do with this. Also strings, you can add choices. So for a string, instead of asking this user for any particular string, you can give them a set of choices. If I can type correctly. So you use curly brackets and then you say like, okay, quick fox, lazy dog is an option. And let's say those are the only two options. So then you finish with a curly bracket. And if you run that and find the string, you're only going to get those two options to select, which can come in handy depending on what type of script you're writing for people. So the rules of these script parameters. So the thing that's cool is you can just copy and paste these and use them in your scripts without worrying about the language. The parameter declarations, though, they begin with this hashtag @. That's how they're recognized by the system, that it's a string parameter or it's the script parameter, nothing else. So you have the variable type and the name that are declared. You can also have outputs. So which we'll use to say like you want to save data in a certain output folder. Yeah, so basically you can copy and paste and use those in your own scripts. And there's two ways. Okay, now we're getting to the good stuff. So there's two main ways to batch process folders, like folders of images. One is using this built-in batch processor. This is a simple tool. This is a good way to start if you just want to quick, I don't know, change the LUT of your like certain channels or something like that. You can declare the input folder, the output folder, the types of files that you process, and then you literally just copy and paste like the code snippets that we were generating with the macro recorder into this box right here, and you can run it. So that's really a quick way to, I don't know, if you just want to quick change something in your images into a whole batch of images quickly, that's a quick way of doing it. So there's another way, which is a little bit more flexible. You can work across multiple folders, subfolders, and this is a template that we have available to you guys that's built into the script editor. So if we open it, I'm closing everybody. Okay, let's just close everything down, just whatever, just discard everything, it's fine. If we open the script editor again and go to templates, ImageJ1 batch, and this process folder in the ImageJ1 macro language. We also have it written in Python and Groovy as examples, but we'll just use the ImageJ1 macro language. And this does the same exact thing as that other tool, except the code that you generate and process for your images goes in here in this process file, which could be called process image instead, but we called it process file. So basically, let's just step through it quickly. We have three script parameters that are being called on the top. We have two different files. One is an input, one is an output directory. So these are the two main directories, and then a string. So this is exactly like that other batch processing method. In this case, we're only going to be processing .tiff images. So the code call, the actual script is all right here. This is it. It's one line, essentially. It's process folder. And then there's two functions that we define below that are gonna do all the meat and potatoes kind of stuff. So process folder gets called, and that basically sorts all of the things inside the folder as a list, and then it goes through each one individually and checks and sees first whether or not it's another directory. So if you're going to have a subfolder in there, and if it's a subfolder, it goes inside and does the same thing and makes a list. So that's what this, if it's a directory, process folder again. So you run this function once again, so it loops again. And you list the things in the subfolder and then check each one if it's directory. If it's the image that you want to work with, so i.e., does it end with this .tiff suffix that you ask the user, like which one they want to use. So it could be a dot, I don't know, whatever proprietary file format you want to process, but in this case, we're just going to use a TIFF. And if it ends in a TIFF, then we're going to process the file, right? We're going to actually do the processing on the image that we want to do. And in that case, it calls this function process file. So we pass through the directory, the output directory, and then the actual file, the file name, and then we start processing that image. Okay. So what's cool here is I have a script example that literally does what we just did to the nuclei, right? Doing the results table and printing them off. If you copy and paste this, if you copy and paste this code, it uses this process folder template. It's exactly the same above, except we also added the min size, right? Because we wanted the user to be able to define the minimum size of their objects. And of course, there's a couple extra things for saving the results. In this one, so the meat and potatoes starts here, right? And this is really essentially exactly what we just like scripted before. So we're just doing the set batch mode to true. We're going to open our image using concatenation, right? So the input directory and then the file name here. So trying to make it as broad as possible. So it'll just process each individual file. We'll duplicate it, do our processing on the duplicate, then activate the original image, overlay them, measure, and save everything. So we're going to save the binary output, so the binary image, so the mask, and we're also going to save the voice for each individual image. And at the very end of all the processing, it's going to save all of the results together in a single image or a single results table. So if we go ahead and run this, it's going to ask us for an input directory. So if you just browse on my desktop, I have that image file saved, and I'm going to just create an untitled folder for the output. So then it's asking me what output do I want to use? Yes, untitled folder. So that's fine. And then we're processing TIFF files, and then I'll use the minimum size 200. So now you'll see it'll just boom. Process every single of those 5 images. There's just 5, but it's good process 100 if you wanted. So now we have now we know that in all those images we have 128 nuclei, and I've got all the printout and everything saved. So if I open that untitled folder, I'll find all of my results saved as a CSV. I'll find the individual binary masks as well as all the ROIs for each individual image saved. So this is like here for you guys. This text example in the slides is here for you to use. If this is something that's applicable, you can also modify it, right, for whatever you need. But this is to kind of get you out there swinging. So, okay, we're at the end. So this is the end. So these are my last top tips. So when you're writing your scripts, these are the things I think are most helpful. 1, use the macro recorder. If you can't remember the code, it's fine. Just run it by hand and then copy and paste, save it. 2, always have that built-in macros function list open so that you can browse through. It's really a lifesaver. 2, print statements are your friends as well, commenting out, right, when you're editing code. But print statements are great because if you're saying, oh, I don't know, this doesn't seem to be processing my image in the right order, print it out, right? Print out the variable name, the file name, so you can see which one is processing at what time. It's really helpful. And then finally, most importantly, ask for help on the forum. If you're talking about scripts and you're saying, I wrote the script, but something's not working, that's fine. Share with us a minimal working example. So like usually an image that you can run it on, and then a piece of code that you can run independently that's highlighting the error that you're finding. Because then we can just copy and paste it and run it on our systems and help you kind of like hack out a solution. Okay, that's it. That's all I have for you guys today. So if there's any questions, just let me know. You can turn your cameras back on too, if you're asking questions or whatever.
Does anyone have any questions? Got about 5 minutes.
Yeah, sorry, I had to rush that one a little bit towards the end. There's a lot of information in that workshop. So.
Oh, no worries. I appreciate you going over the coding as well. That was nice. Okay, it doesn't look like we have any questions. Well, I'd really like to thank you for an excellent job on these last 2 sessions, and I think we've all learned a lot. I'll be editing the video, sending it out in the next email, so everybody look for that. And if they want to reach you, is it the same forums and everything?
Yeah, so on the forum, you can mention me. So it's at ETA Dobson is my name on the forum, ETA Dobson. And you can also email me, ellen.dobson@wisc.edu. Either way, it's fine.
Perfect. Well, thank you, everybody. And thank you, Ellen. And with that, see you next week, everyone.
Thanks, everybody.